Hello everyone, today we are continuing telescopic series part 2. Part 1 is done already where we have discussed what is a telescoping series, how to find the sum of a telescoping series where each term can be expressed as difference of two terms. Finding the difference when you take the sum of the series, then most of the terms get cancelled except a few. Maybe first and the nth term left, maybe only first term is there. But before we find that partial sum, we need to know whether it is going to be a telescoping series or not. If it is telescoping series, then be sure that we can express each term as difference of two terms. But if it is not telescoping series, then you won't be able to do. So today's class on telescoping series will be on identification of telescoping series first. Then we will solve lots of sums to understand how to find the sum quickly. See, sum of a series can be determined by any method. Sigma n method, sigma n square, sigma n cube, you have already done. But here, if we know telescoping series, finding sum will be just within a few minutes, maybe a few seconds also. It depends on your ability whether you can apply the concept very fast or not. So without wasting our time, let's start with understanding of telescoping series first. Identification of telescoping series. This is a special type of infinite series. You must note it down. First, let me clarify. I am talking about infinite series, but last class I told you find the sum up to n terms. Will it be correct to say find sum up to n terms? Of course it is correct, but that sum must be referred as partial sum. Infinite series is the series. Series cannot have finite number of terms. When we take finite number of terms, we find the partial sum for that purpose. Maybe we are taking the sum of 20 terms or 30 terms or n number of terms. But series is infinite where terms are written by using the plus sign in between them. Continues this manner. If it is a series or infinite series, it will be always like this: u1 plus u2 plus, it continues this manner, plus un plus, it will continue up to infinity. When you consider only sum of these terms, then this will be referred as partial sum. Okay? So we must remember that a partial sum of infinite series can be determined. And we are discussing a very special type of series which is known as telescoping series or telescopic series. But understanding whether it is telescoping or not is very important. Otherwise, we will try to express this one as difference of two terms, you will never get the success. Okay? So we'll understand what is a telescoping, how to rectify, how to understand whether it is telescoping or not, and then we'll be using the concept we have already learned. What is the concept? We have written the nth term in this form, that un minus un plus 1. The nth term you have taken Tn you can write this manner. Then what is Sn? Sn is nothing but sigma Tn. You take I equal to or n equal to 1 to n, sigma Tn, and it is from n equal to 1 to n. What will be n equal to 1 to n? What will be remaining terms over there? This is going to be u. You just write it here. It is u1 minus u2. First term t1. I just remind you what we have done in the last class. u2 minus u3. Remember it? Then Tn is what? Un minus Un plus 1. So just these terms getting cancelled. What is remaining over there? That is u1 minus un plus 1. Isn't it? So if it is telescoping series and you have expressed sum this manner, up to nth term sum is u1 minus un plus 1. But you can say that what is the problem if you write Tn in this form, un plus 1 minus un. In that case, there is no difference, that Sn will be just this one will come first. Sn will be n equal to 1 to n Tn. This will give you just un plus 1 minus u1. We will use this result directly to find the sum of a telescoping series. Okay. Even you have expressed the series in this form. Let Tn equal to un minus un plus 2. There also that sum, if you consider sigma Tn or Sn, will be equal to what? You just put n equal to 1 to n, then sigma Tn will be u1 minus u3 plus u2 minus u4, like this, and you can see that terms getting, just let me check. If you put n equal to 1, u1 minus u3, u2 minus u4, then it is going to be 3, u3 minus u5, and then 4, that is u4 minus u6. You can see these terms getting cancelled, u3, u3 here, u4, u4 here. This way also you can find the sum. Okay. So here few more terms will be there. Here you observe that when you finding Sn for this series, after expressing un minus un plus 1, only this thing remaining. And if you have expressed this manner, only this thing is remaining. But here few more terms will be there, like you can see that u2 not getting cancelled, u1 not getting cancelled, but u3 here getting cancelled with this, u4 here getting cancelled with this. Just few more terms will be remaining over there. Let us do experiment with this process first. But before that, I told you we'll understand whether a given series is telescoping or not. I am discussing in brief, which is very common observation, characteristic of telescoping series, alternate signs. I mean plus minus this one. Cancellation of intermediate terms we have seen before. So here minus half, plus half, minus 1/3, plus 1/3, all these are alternate, and that's why getting cancelled. So this is a telescoping series, and this one is also a telescoping series. Okay. Apart from alternate plus minus signs, they are getting cancelled, some series may be given in hidden form. You have to understand this one is a telescoping series just by making some observations, like they may have common factors. Terms may be in, each term is composed of product of R terms in AP. First factor of each term are in the same AP. This way also, you just see this one. Apparently it seems that it is not telescoping series. We cannot express this one as difference of 2. But we can. Why? Because 1, 4, 7, 10, 4, 7, 10, 13, 7, 10, 13, 16, they are in arithmetic progression. And if you observe those first terms of each product, every first term of the product, just see 1, this 4, this 7, they are in the AP. Which AP? The AP given over there. 1, 4, 7. Here 4, 7 common. So 4, 7, 10 common. So 1, 4, 7, 10, then 13, then 16. This is an arithmetic progression. All these first terms are in the same arithmetic progression. So this is another way to identify telescoping series, and be sure that we'll be able to express it as difference of 2 terms. Similarly for this one, terms they are in the denominator, but you can see that 1, 3, 5, 7, 9, 11, 13, they are in arithmetic progression. And this first term 1, 3, first term here. This one 5, they are in AP. So this is a telescoping series. Next one, numerator also contain terms like 4, 5, 6. But here 1, 2, 3, 4, 5. They are in AP, and the first terms again they are forming AP, and that AP is the same as it is given in between these terms. 1, 2, 3, 4, 5. Here we get first terms in this form. So this must be a telescoping series. But next one is not a telescoping series. Why this one not a telescoping series? You will say that 159 there in AP, common difference 4. 24, 216 there in AP, common difference 4. 37, it's fine. But where is the AP? Term 1, 5, 9, 10, 11, they do not form an AP, although this 1, 2, 3 are in AP. I hope all of you are understanding. This is not a telescoping series. Why? Because 1, 2, 3, although they are in AP, but they are not terms of the AP given here. 1, 5, 9, then next 10, 11. They are not terms of this series. So this is not a telescoping series. If you waste your time with this kind of series by using the method we are going to devise to learn today, you will be wrong. You will never get it by this method. Okay? Now I am going to tell you how to find the sum of telescoping series when the terms given in denominator or terms given in numerator. Okay? Let me start with the easiest one, which apparently seems that not a telescoping series, but by its own right it is going to be a telescoping series. Why? How? Here, if you are going to find the sum of this series, you can easily express like the first term as you multiply by root 2 minus 1, numerator and denominator. It will be root 2 plus 1, root 2 minus 1, 2 minus 1. Second term is root 3 minus root 2, and denominator will be 3 minus 2. We have multiplied by root 3 minus root 2 numerator and denominator. The third one, root 4 minus root 3. Here it is 4 minus 3. This way, if you continue, the last one going to be root 101 minus root 100 by 101 minus 100. So 1 is common to each factor. And you can see that this is a perfect telescoping series, and the way it is given, we need not write the general term. It is quite obvious which is going to remain after cancellation of terms. That is root 101 minus 100. You see these terms are getting cancelled. Okay. So every time here cancelling with the second term, so this will be cancelled, remaining is this one and this one. Sum is root 101 minus 1. Alright. Is this a telescoping series? For this sum also, I am not going to devise any method. I am not going to tell you any different method. Here we can do it by observation only. How to? You just write the given series in the form. This 4, this is 4 into 7, this is 7 into 10. So let us write in this manner, 1 into 4 plus 1 by 4 into 7 plus 1 by 7 10, and this is 1 by 101 into 98. Now difference is 3 over there. Here also difference 3, just product of two terms. So we can write it this manner, multiply by difference of these two. This we are going to apply for next sum also, where we find product of three factors. And this 4 into 1 you write this manner, 4 minus 1 by 4 into 1 plus 7 minus 4, 7 into 4 plus 10 minus 7 by 10 into 7, this plus 101 minus 98 by 101 into 98. Now start writing this one as difference. It is 1 minus 1 by 4 plus 1 by 4 minus 1 by 7. I think all of you have understood what we are going to get there. That is 1 by 7 minus 1 by 10, and this way 1 by 98 minus. So this is a perfect telescoping series, and terms are getting cancelled. Many terms are getting cancelled. That 1 by 4, 1 by 7, all this getting cancelled. What is remaining over there? It is 1 minus, till this everything get cancelled. So there will be, except the first and the last. So 3 into 101 LCM, there will be 100. It's alright, no? You understand? This will be 100 by 303. Problem 3 will give you some trouble, because here there is product of 3 terms. If 2 terms are there, that you can manage by writing difference the way I showed you. But if 3 terms there, then this will be telescoping. Why telescoping? That I have explained. Because those first terms, they are in AP. Then the same AP where 1, 4, 7, 10, 13, they form an arithmetic progression. So it is a telescoping series. But here we have to do one thing. We should generalize. We should rewrite the general term, writing this manner. That general term will be now general term into last factor minus first factor divided by their difference. What you are doing? Last factor minus first factor divided by their difference means you are multiplying by 1. But this you have to do to express this one as sum of 2 terms. Okay. So before we apply this method, let us know the general term here. You can easily find the general term. That Tn you can find, it is nth term of 147. Nth term of 147 is what? 1 plus n minus 1. This multiplied by 3. This 4 plus. Next one will be 4 plus n minus 1 into 3. And next one 7 plus n minus 1 into 3. Every time n minus 1 into 3. So this one will give us 3n minus 2. This one 3n plus 1. And this one 3n plus 4. Okay. So write the general term here. Tn. Tn is what? 1 by 3n minus 2. This multiplied by 3n plus 1 multiplied by 3n plus 4. Then what you are going to do? You are going to rewrite this as, the general term will remain as it is. Just do one thing. This last factor is what? This one. The first factor is this one. In the numerator you write that. Their difference. The last factor minus the first factor divided by their difference is what? 6. So you are multiplied by 1. What I was telling you. Now keep 1 by 6 outside. Okay. Then this you write 3n plus 4 divided by 3n minus 2, 3n plus 1, 3n plus 4 minus 3n minus 2, 3n minus 2, 3n plus 1, 3n plus 4. So these two get cancelled. 3n minus 2, 3n minus 2 also get cancelled. You can write 1 by 3n minus 2, 3n plus 1, 1 by okay, difference we have done. Then what is the sum? I told you, you write this one as un, this one as un plus 1, or this one un plus 1, this one un. You have to express this one as difference of 2. But is it ensured that this one un to this one will be un plus 1? Let us check. Un is what? 1 by 3n minus 2, 3n plus 1. Un plus 1 will be what? You just replace n by n plus 1. 3n plus 1. N by n plus 1, if you replace 3n plus 3 plus 1, that is 3n plus 4. So it's alright. It's okay because this is going to be un minus un plus 1. And if Tn is in this form, Sn will write by the method we are using it. We have used before, now also. Sigma Tn, n equal to 1 to n, it is 1 by 6. What will be remaining over there? There will be u1 minus un plus 1. Okay? This we did before. So Sn is sigma Tn 1 by 6 u1 minus un plus. See how fast, how easily we are getting the sum. Now we will replace u1. u1 is what? Just put n equal to 1 over there. 1 by 1 into 4 minus 1 by 3n plus 1. I hope all of you have understood. This is a huge problem. We get it by using this simple technique, by expressing this one as sum or difference of two terms, and then by remembering the fact that if it is un minus un plus 1, then sum is u1 minus un plus 1. Okay? So let us see the next problem. This is another problem which I have hinted you earlier that this is also telescoping series, although these are varying. When in the denominator we observe that they are forming arithmetic progression. 1, 2, 3, 4, 5, they are forming arithmetic progression, and those first terms are in AP. This will ensure that this is telescoping. So what we are going to do there, again the same manner, we will be writing the nth term here, just within a minute or few seconds. You always do faster than me, so you can do it within a second. What is the sum here? But this sum might give you some trouble. Let me complete this. Tn you write, see 135 its nth term, all of you know, 2n minus 1. And here 1, 2, 3 nth term is n, this is n plus 1, and this is n plus 2. N is coming over there. So that method, if we write the difference, it will not work, at least in the beginning. So what we are going to do there, we rewrite Tn as 2n by n, n plus 1, n plus 2 minus 1 by n, n plus 1, n plus 2. I think all of you have understood. N getting cancelled. Here 2 by n plus 1, n plus 2 going to be telescoping. N plus 1, n plus 2, just like the previous sum, going to be telescoping sum. Okay? So you write Sn. Okay, let me simplify. Let me go a bit slow for you. You write this one as n plus 1, n plus 2. What to do? Even for two terms you can use the approach. That 2 by n plus 1 you keep outside. 2 by n plus 1 and n plus 2 you keep outside. Inside what you will do, you will write in the numerator as difference of those two. See, we have done it for 3 terms. Here I am doing it for 2 terms only. And this difference is 2 minus 1, that is 1. You write. Done? So this part let me simplify it for you first. Once you are taking it inside and dividing, it is going to be 1 by n plus 1 minus 1 by n plus 2. So this is of the form un and un plus 1. Let's see about this one. This will remain as it is, n, n plus 1, n plus 2. What manipulation, what modification we are going to do? Numerator we are writing n plus 2, the last factor, minus the first factor, divided by the difference. It's alright. Last factor n plus 2, first one n. Numerator is difference of 2, that divided by the actual difference. Okay? So here also, by keeping half outside, you write n plus 2 by n plus 1, n plus 2, and this one minus n by n plus 1, n plus 2. So here n plus 2 getting cancelled, n also getting cancelled. Alright. Now this we rewrite once more just to get the steps together and to identify whether we are getting even minus, even plus 1 form or not. n plus 1, now after doing 3-4 sums, you all have understood if this is un, this will be un plus 1. If this one un, this one will be un plus 1. So directly we apply sigma sign on it. Sn will be what? Sigma Tn. 2 into what? This result will be same, that is u1 minus un plus 1. u1 is what? 1 by 2 minus n plus 2. And this one is what? u1. u1 is what? 1 into 2 minus, this is un plus 1. 1 by n plus 1, n plus 2. This is such a big sum, such a difficult sum. You have reduced into this simple result, and this is coming to be 2 into half 1 minus 1 by 4, that is 3 by 4 minus 2 by n plus 2 plus 1 by 2 into n plus 1, n plus 2. Okay, this is the sum. Now if they have asked you to find sum up to infinite number of terms, for infinite number of terms you will write s infinity equal to limit n tending to infinity. Which one? 2 by n plus 2. 2 by n plus 2, if you put infinity in the denominator, it's a huge quantity in the denominator, it will be reduced to 0. And the second part, this is the first part, 3 by 4 will be remaining over there. This one, what happens? If we apply limit on this, plus n tending to infinity 1 by 2 n plus 1, n plus 2, this is also reducing to 0. So this sum, what you have taken here, the sum up to n terms will be reduced to 3 by 4 only if we have taken the whole series. Whole series means that infinite series we have taken, the sum will be reduced to 3 by 4. This concept you keep in mind. Sometimes question is asked for infinite series, not partial sum. All these sum up to n terms was partial sum, but this is sum of the whole series. This one looks big, but after writing the nth term, we can reduce it to a very simple one. Like, we'll write the nth term here, Tn. Tn is quite obvious. This is a telescoping series. I need not explain, already explained why telescoping. So it will be 1 by nth term of 1, 2, 3 is what? N. Nth term of 2, 3, 4, 5, n plus 1. Nth term of 3, 4, 5, n plus 2. And next one will be n plus 3. This is telescoping. And we'll rewrite, we'll modify this nth term by multiplying and dividing by the difference of the last and the first term. This will remain as it is, n plus 1, n plus 2, n plus 3. Numerator, what you will get? What you have to get, what you will get, no? You have to get n plus 3 minus n by the difference 3. So simple. This you write 1 by 3. Now take this one inside. N plus 3 by this whole thing. What will you get? N plus 1, n plus 2, and this is 1 by n plus 1, n plus 2. In JEE you have to write the answer. In Olympiad, if you reach the INMO level, then you have to solve it, because question should be descriptive. Okay, even RMO also questions will be descriptive. There you have to write details, but you have every right to make it simpler. You have every right to make it short. You can find the answer in 3 steps. If you know the technique, then you must write the answer. Like this one, Tn is this. What is Sn? It is going to be sigma Tn, n equal to 1 to n. This is say un. I mean 1/3 multiplied. This is un. So this one un plus 1. So what is the sum in this case? It will be u1. Put n equal to 1 over there. 1, 2, 3. This minus un plus 1. N plus 1, n plus 2, n plus 3. This is done. Sum is done. Such a big sum. No partial fraction. No other method. Just modify the nth term and get the sum. Okay? This question is a bit complicated, and the question is linked with one IOQM 2021 question. They have asked till n equal to 1999. But if you know it for where there contains n number of terms, it will be easier to manipulate any number of terms over there. Okay? So let us do it. Whether it is telescoping or not, you won't get. This is Olympiad problem. In the first step, you cannot decide. You have to go for manipulation, and then you have to express it. This one as difference of 2 terms. Then it will be telescoping series. At least you will be able to understand. Tn is quite obvious that Tn is under root n square n plus 1 whole square. So there will be n plus 1 square into n square, n plus 1 square, and this plus n square. Alright. So you can take something common from there, you can expand it also. What you will do there, that you write n square plus n whole square, n square 2n plus 1 plus n square. So this thing is changed to under root n square plus n whole square, n square 2n square, and here also you take n, you take inside, it will be n square plus n whole square. Okay. So numerator is a perfect square, a square 2ab plus b square form, and Tn you can write then n square plus n plus 1 whole square, square root, it will come out, and this is n square plus n. So this is 1 plus 1 by n into n plus 1. So Olympiad sum. Directly question will not be asked that this is a telescoping series, you find the sum. But you can find the sum this method. Sn will be equal to what? 1 occurring n times, sum is n plus sigma 1 by n, n plus 1. Alright. This you can express as difference of 2 terms plus sigma 1 by n minus 1 by n plus 1. You use the method or do it by observation. By hook and crook you have to get. You will not always get the convenient form. You have to think, you have to apply as fast as possible. Method will take time, but if you can finish it by observation, you do it. What is this? This is un, and this is un plus 1. What is the sum then? Sigma sign I have taken here. Over this, if we apply sigma sign, u1, that is 1 by 1 minus n plus 1. Finished. Such a big sum, apparently it seems not big at all. This will be n by n plus 1. It is finished over there. Okay. Now you put n equal to whatever given in Olympiad problem. But sum is given this form, then you can find sum up to any term. This is of course a telescoping series. Okay. Can this be a telescoping series? After getting this kind of sum, what you will do, you will write the nth term first. Then decide whether you can express this one as difference of two terms or not. What is Tn over there? Nth term of 1, 2, 3, it is n. And in denominator, it is 1 plus 1 is changing to 2. This is 2 square there, 3 square. So it will be 1 plus n square plus n to the power 4. There is a hope because n to the power 4 plus n square plus 1, we can easily write n square whole square, 2 into n square into 1 plus 1 minus n square. It is n square plus 1 whole square. Little chance I see that can be changed to a telescoping series. Or it is already telescoping series, we have to find just the sum. But you have to understand, we must have the courage to start. Nth term I have written, then we are getting the secret of a complicated nth term open. Why? Why I am so confident? First thing, I observe that this one going to be difference of these two, isn't it? N square plus n plus 1 minus this, if you do, difference is 2n, not n. Okay, I agree, this is 2n. So you make it half into 2n. This by plus 1 n square n plus 1. And then write, because you are going by common method, no? What is the common method here? If you are still confused, let me explain. The same technique I told you, I am rewriting that manner only. What I will write? The nth term as it is. Nth term as it is. N plus 1. And there it will be difference of these two. N square plus n plus 1 minus this divided by their difference is what? 2n. So these 2n getting cancelled. Okay. So this you write half into, take this one inside, then n square n plus 1 by this, it will give you minus 1 by n square n plus 1. Now somebody has taken un equal to half 1 by, if you have taken, what un plus 1 going to be? Un plus 1 you can find easily. Un plus 1 will be half into, just replace n by n plus 1. Okay. This plus 1. Half into, you simplify it. N squared 2n minus n, n, and 1 minus 1 get cancelled. See, we have got this. We have got, if this one un, now this one going to be un plus 1. So everyone can write Sn from here. Sn is what? It is sigma Tn. The sum is n equal to 1. That is 1 minus 1 plus 1. 1 minus this. Alright. So the sum reduced to a very simple form, half n square n by n square plus n plus 1. Okay. How can this be a telescoping series? Anyway, does it look like a telescoping series? Answer is very simple. No. But yes, it is true that it is a telescoping series. What I told you in the previous sum, you need to write the nth term. Target the nth term, writing the nth term. It is not very easy to write the nth term here. Numerator you can manage, but denominator you have to make some observation. There is 5. there is 65, there is 325. How can you write this? 65 and 5. There is a relation. It is 30 into 5. Another relation is there. 5 we can write 4 into 1 square plus 1. 65 we can write what way? 4 into 2 square plus 1. No, it is not. So think first, how do you write 65? Just make a little change here. You write this one 4, this one also 4. Various methods are there, but I am not here today to explain all those methods. Let us find it by observation only. The beauty of telescoping series we will disclose gradually in the following sums. So you are least bothered about to find the nth term here. You get it by any method, doesn't matter. See, it's coming. 4 into 16, 64 plus 1, it is come. 325, how to write? Try. It is 4 into, must be 3 to the power 4 plus 1, 81 into 4, 320, yes. So Tn we can write as, numerator is okay, 8 into 1, 8 into 2, 8 into 3, you write just 8. And denominator is going to be 4 n to the power 4 plus 1. And this factorization you have seen in many places. Because 4 n to the power 4 you write 2n square whole square plus 1. 2 into 2n square you add. And this you subtract also. So it is 2n square plus 1 whole square, 2n whole square. Going to be 2n square. This multiplied by, okay. So here you write the nth term as 2n plus 1. Can you write this one as a telescoping series? We can. How? Why? Because like previous sum, this minus this is 4n, not 8n, but doesn't matter. 2 into 4n you write. The manipulation I told you, the modification I told you of nth term, sometimes can be done by observation also. You just write 2 into 4n. That 4n you write in the form 2n square minus this divided by so I hope this is also telescoping series. Just let us rewrite. It is 2 into, now if you go by division, this is going to be 2n square minus 2n plus 1, 1 by 2n square plus 2n plus 1. Alright. Now check. If you have taken un equal to 2 by 2n square minus 2n plus 1, un plus 1 actually what? 2 into n plus 1 whole square, 2 into n plus 1. Yes, because 2n square will be there, 4n minus 2n, it's coming that one. So it will be 2 into un minus un plus 1. Now what is the sum here? That Sn going to be equal to sigma Tn 2 sigma un minus un plus 1. Even you need not write all these things. You just know it and apply. You put n equal to 1 over there. That is 1 by 2 minus 2 plus 1 and this term. The first term by putting n equal to 1 and the last one. That is done. So the sum is 2 1 by 2n square 2n plus 1. Alright. Really it's a difficult sum. Problem number 9, where the nth term is also very complicated. Fourth power is there. How to simplify it? Can this be a telescoping series? You will say that chapter you are doing on telescoping series, it will be. Actually, I have chosen some in such a manner that can be reduced to telescoping series. Okay, all the sums. For any problem, you will write the nth term and from there you will decide. Nth term, to modify the nth term, check whether we can express this one as difference of some extra terms can be there. We don't care. But let us see what is happening there if we try to modify it. There is a problem. This is fourth power and this is quadratic. For this kind of problem, you need to reduce the degree of n in the denominator. Otherwise, the difference method which I have discussed will not work. So our first part will be that only. We will try to reduce on dividing. So Tn is n to the power 4 by 4n square minus 1. So this you write 1 by 4 n to the power 4 by, don't multiply, keep it that form only, because there is a chance of expressing numerator in this form. Now what I am doing, multiplied and divided by 4, I am writing 2n whole square. No, can I write this one as 4n whole square? We have to check all these things, whether we can do it or not. But it will be better if you go for division directly. 4 into the power 4, if you divide by 4n square minus 1, it will be plus n square. Then you write 1 by 4 here. So now we can write Tn in this form, 1 by 4 the quotient plus 4n square minus 1. I think we can prove now it is telescoping or not. This you write 1/4 n square 1 by 16 plus 1 by 16 2n plus 1 2n minus 1. Summation of this part will not create any problem. The problem will be for this part. If you can express it in the telescoping form, then it's fine. You just write that this one as 1 by 2n minus 1 minus 1 by 2n plus 1. I think it is working then. You write n square by 4 plus 1 by 16. What is the difference between these two? We are modifying the nth term here. Difference between these two is 2n plus 1 and divided by 2, and this part will remain as it is. Okay? So this you write n square by 4 plus, now separate. This you take inside. So it will be 1 by 2n minus 1. This is our Tn now. Now think, is it un plus 1 form? Yes, of course. If this is un, then this is un plus 1. Now we can go for finding sum of n terms. It will be sigma Tn, sigma n square by 4. This will come n times, you write directly. Put n equal to 1 over there and this one as it is. So here it is going to be 1 by 4 sigma n square, you all know, n plus 1 2n plus 1 by 6. this plus you simplify or not, it's up to you. See the option and check. Okay, sum up to n terms is fun. Why have I chosen this sum? One similar problem. It is because of this statement, sum up to infinity. Okay, this is telescoping series, and you know how to simplify the nth. This nth term, if you write here, Tn equal to 1 by nth term of 147, 1 plus n minus 1 into 3, 4 plus n minus 1 into 3. This kind of sum we have done before. This will be 7 plus n minus 1 into 3. Just let me show you application of that infinity concept here. That is 3n minus 2, 3n plus 1 and 3n plus 4. Alright, Tn equal to this thing. So let us modify the nth term here. The last factor is 3n plus 4. First one is 3n minus 2 by 6. I think all of you can understand these steps now, because all similar problems we are solving here. So 1 by 6 now separate. It will be 1 by okay. Now Sn will be what? Sigma Tn, and this one is un, means this one un plus 1. So sum is 1 by 6, put n equal to 1 over there, 1 into 4, 3n plus 1, 3n plus 4. But the problem is find sum up to infinity. I mean whole series, it is not partial sum. So S infinity, you just apply limit on this, 1 by 24. Infinity is a huge quantity. Even if you haven't done limit problem before, don't worry, because if you put infinity over there, this will make the denominator huge, the result will be 0. So it is 1 by 24. Okay. Structure may look different, structure may be very difficult. I mean, you doubt whether it is telescoping or not, but you have to check with the nth term always. Let us find the nth term first for this problem. Tn going to be what? 1, 2, 3. n is there. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power n will be there. And here it is n plus 1, the nth term, into n plus 2. Can this be telescoping? Let's see. This is also telescoping series. 2 to the power n may be multiplied over there, it doesn't matter, but it is telescoping. But for you, this may be different. I'll discuss in another video that where how to simplify this kind of things by using partial fraction. But this time I am doing it mentally. It is n by n plus 2, n plus 1. See, we have to adjust n over there. So what I am doing there, writing this one as 2 by n plus 2 minus 1 by n plus 1. Okay? Is it correct? 2n plus 2 minus n minus 2. Coming n over there. So you can split this manner. So Tn actually going to be what? 2 to the power n plus 1 by n plus 1 plus 1 minus 2 to the power n by n plus 1. I have written this thing intentionally. Why n plus 1 plus 1? M is clear. I am seeing this one as a telescopic series. If I have taken this one as un, this time it is changed. This will be un plus 1. Isn't it? See, you just change n by n plus 1, you will be getting this. Am I clear? I hope all of you have understood. So this time, what will be the sum? Sn will be sigma Tn. This is sigma un plus 1, putting 2 to the power n by n plus 1 factor later, minus un. What does it give? That I have explained already. It will give you un plus 1 minus u1. What is un plus 1? What is left over there? Quite obvious. 2 to the power n plus 1 by minus u1. What is u1? Just put n equal to 1. 2 by 2. That is 1. Answer the time. So Sn is going to be, for this complicated series also it was telescoping, and the sum is n plus 2 minus 1. Okay. This is another type of telescopic series problem where product of terms given in the numerator. And here modification of general term will be this manner. General term will remain the same, but we are modifying it. How to? We are writing general term into extra factor on right side of the last term. What is this? I will explain. Extra factor on left side of the first factor. Divide by their difference. So again the problem is that we have to write the nth term. We have to take one factor extra on right hand side, one factor extra on the left hand side. Denominator you divide by the difference and then proceed. Okay. So let me start the nth term. Again the problem is writing nth term. You write as fast as possible, then it is done. For first one, what is the nth term? Tn will be nth term of 1, 2, 3, n, 2, 3, 4, n plus 1, and 3, 4, 5, n plus 2. Then this Tn you have to modify. How to modify it? We will write one term extra. You write n plus 1. In the numerator, on the right side of it, what will you get? N plus 3. Left side, what will you get? Before n, in this progression, n minus 1. And the difference is 4. You write. Such a beautiful subject, such a beautiful topic. You must learn with proper care. This Tn is now 1/4 n plus 1, n plus 2, n plus 3. This minus n plus 1, n plus 2, n minus 1. We need not put values. This is just a telescoping series. We'll check if this is un, whether this is un plus 1 or not. Really it is un plus 1. On it you replace n by n plus 1, we'll be getting this thing only. n plus 1, n plus 2, n plus 3. So that you have expressed Tn in this form, un plus 1 minus un. Sn going to be what? Sigma un plus 1 minus sigma un. And what is the sum of this? I have explained in many sums. It is un plus 1 minus u1. Sum will be un plus 1 minus u1. No need to put the value. Just remember, if un plus 1 comes first, it will be un plus 1 minus un. If un comes first, it will be u1 minus un plus 1. What is un plus 1? This is n plus 1, n plus 2, this by 4 minus u1. u1 is what? Put n equal to 1, it is going to be 0. So sum is done. So in today's class, what you have learned? You have learned telescopic series, how to find the sum very first. We need not put even values. Just by remembering that, it will be u1 minus un plus 1 or opposite. Expressing the nth term in that form and then taking summation straight, it will give you the sum. I have discussed many sums with you. I hope all of you have understood. You can apply it in solving problems from telescoping series for JEE as well as for your Olympiad examinations. Thank you.